So in this video, we're going to talk about the IUPAC nomenclature of organic compounds. So first thing you need to know what will be the parent name for various homologs that are present, okay, in an organic compound. Yeah. So if you got the alkenes, right, the parent name ends with an ANE, okay, that is going to be an ANE. You really would want to write these stuff down. So the parent name of an alkene ends with an ene. If you got an alkene, that is going to end with an ene, or yeah, basically an ene. This is a suffix of any molecule that ends with an ene. And you could also have alkynes. Okay, so that also ends with a yne. And there might actually be a pattern that is created from here. If we talk about alcohols, you can see where this is actually going. The parent name for alcohols would obviously end with an well. So you want to write out all the other homologs and find out what will be the ending suffixes for each of them. Okay. So that is the first stuff you gotta know. Now, secondly, you gotta find out how many substituents are present. Okay, on the ring of the organic compound. If there is actually substituents, then you need to name them first. Okay, substituents must be the first named in organic compound. Now, examples of substituents are that is alkyl groups, that is R groups. You could also have NO2. The nitro groups, you could have X. These are the halogens. You could also have other ones like what's that gonna be now? So really, these three most times are the most abundantly seen. So basically, if you have this stuff present on the parent chain, you need to name them first. Now, in naming this stuff, you need to write out what will be their positions. Okay. Now, these positions must be represented in Arabic numerals. Okay. So you could say one alkyl group or one methyl. If you talk about one methyl, first of all, we need to write a 1 and a hyphen, okay, not a comma. So 1 methyl means that the R group, the methyl R group, is on position 1 of the carbon atoms in the parent name, the parent chain. If we have 1, 1, then this is actually representative of 2 positions. Although this is actually the same positions, just that you have more than one alkyl group or more than one substituent present on the position 1. If this is actually representative of one type of an alkyl group or a substituent present on the first position, then you need to write it in two places, 1, 1, representing the fact that there is 2 of those substituents present on the first position of the parent chain. And since you got 2, you need to represent it in Greek form. So that will be dimethyl. If it's actually the methyl group present there, then you're going to say dimethyl. Okay. Yeah. So this is typically what you got. Basically it. Okay. Now, what if you have more than one type of substituent present on the parent chain? How would you actually name it? So the next thing is you need to follow the alphabetical order. Okay. Now, the alphabetical order is basically a type of nomenclature that follows the most alphabetical arrangement of the names of the substituents that are present on the parent chain. Let us say you had a chlorine atom present. Let us say you have a methyl group. Let us say there is an iodine compound there, and we got a nitro group also. So this is an iodine atom, not a compound. Now, as you well know, the name of this is chlorine. The name of this is methyl, this is iodine, and this is nitro. So in alphabetical order, this is going to come first because C is literally the third alphabet of the English language. So this should come first. Then this is going to come second. Now after M, we got an N. So basically that is what you're going to do. You're going to arrange them in alphabetical order in order to find out the true form of the IUPAC. Now, you also need to take note of the functional groups that are present there. Okay. Now, if you got the functional group present in the parent chain, let us say there is the alkene, right, and then there is also the alkanol functional group present. What will be the parent name? Because here there is the functional group corresponding to the alkene present, and there is also the functional group corresponding to alkanols present there. So in that case, we're going to check out for which one is the most reactive between alkenes and alkanols. Which one is going to be more nucleophilic? That is the one that is more reactive. Now that is basically going to be the alkanols. Really, as we go down the homolog, we actually have increasing oxidation states. So this stuff actually has a higher oxidation state as compared to this. So because of that, we're going to name the compound with respect to alcohol. Now the alkene group will only serve in a position. Now, if you want to tell the position where the double bond is, because we know this is basically a C double bond C at some position within the compound. And if you have that, you're just going to tell the position where that is. If you are moving in this position and this is carbon 2, you're just going to say 2 in and you go on. If you have more than one double bond, that will be di-in. If you have it as 2, if you have it as 3, that will be tri-in, and so on and so forth. And so you're also going to tell the positions where the double bonds are, okay? So basically that is it. Now, I really just want us to go into some questions now so that we could understand how this stuff really works. Okay? Yeah. So let us try naming this compound. Let's say you got this. What is going to be the name of this compound? So first of all, we need to find out what is the longest chain. Before I do that, we're going to change this into its condensed physical form. This is called the line structure. By the way, I've actually made a video that explains how to change this stuff into its condensed form. So feel free to check that out on the channel. Now at this terminal position, there is actually a CH3 group. So I'm going to represent that there. And then at this position, there is also another one. Here, there is actually going to be a CH. That is because carbon atom actually needs 4 bonds. There is already 3 created here. So we should have just one more. So this is what we got. Then here, okay, so here we got a CH3. So that is a CH3. And going up, we got a CH2. This is a CH2, okay. And here we have a CH again. And up here we have a CH3, okay. So there is a Br here. So the first thing we need to do, we need to count out what will be the longest chain in this stuff. So I'm going to start from this side. Now, why am I really doing that? Why am I starting from this side? This is actually because we got a substituent at this position. And we want to make the position of the substituent be the lowest that it could be, which is actually the reason we need to come from this side. Okay? So this is going to be carbon 1. So this is carbon 1, this is carbon 2, this is going to be the third one, this is the fourth, this is the fifth one. So on carbon 2, there is a bromine atom. So that is going to be 2 bromo. So let us write it out. So immediately after I write the position of the substituent in question, I need to draw a hyphen before writing the name of the substituent. If it is a bromine atom, that is going to be a bromo. If you got an iodine, that will be an iodo. If you got a chlorine atom, that should be a chloro. And you're going to tell us what is going to be the name for fluorine. Okay, so this is 2 bromo. And then we also got another alkyl group on position 4. But this is more alphabetical to this, because this is methyl. So that is actually on track. That is 4-methyl. Now immediately after you write this, the first letter for your name should actually begin with a uppercase letter. Now every other thing remains in lowercase, small letters. So this will be 4-methyl. And then we're going to have a full 5. 5 corresponds to pentane in it. So this is going to be pentane. So that will be the name of it, 2-bromo-4-methylpentane. Now this stuff could also be written in another way. You could write it this way. This will be CH3, and we got a CH with a CH3 in the bracket, which represents a drop down. And there is a CH2 here, and there is another CH with a Br again, and you got a CH3. So you could actually be given this and asked to tell the name of it, like more typically so. So we're going to take more questions that look just like that. Now let us see, we got this one. Yeah. So if you have this and you were required to tell the name of it, as usual, we're going to change it to its physical condensed format, which is going to be from this position. We're going to have a CH3 at that position. Now this stretches to this position where there must be a CH2. So I'm going to write a CH2 there. And here we got something going on. There is a carbon atom here. And as you can see, there is already the 4 bonds that this carbon atom needs. There is the bond stretching to this drop-down methyl group. And there is this bond, which is the second. And there are 2 other bonds to that direction, making it 4 for that carbon. So this is going to be a C. I'm going to have a C with a CH3. And then we're going to have the second C, which contains just 1 hydrogen atom. Okay. So that will be CH. Okay. Now here we're going to have a CH2 with an OH. So basically this is what you're going to have. Now more typically so that you will be given this one rather than this. But don't get me wrong. You could also be given this one to find out the name of it. So if you have this and you want to find out the name of it, the first thing we want to do, we need to find out what will be the position of the substituents present here. So as you know, there is only one substituent. That is the drop-down methyl group. This is not a substituent. This is a functional group. Now this is another functional group. Now because we know that the alcoholic functional group is more reactive as compared to the alkene group, we're going to start from this side. Now even if that weren't so, we should have still begun at this side because if we move from this side, that will make these positions higher than if we move the other side. So that is still going to work. So this will be the first position. This is the first carbon atom. This is going to be the second. This will be the third. This is the fourth. And this is going to be the fifth. So we know that between 2 and 3, there is the double bond. Now, obviously, you know we're moving in this direction, in it. And because of that, this 2 will be the one that faces this double bond, making that double bond to belong to it. Another way you could actually get it is the fact that between 2 and 3, the smaller number should be taken if you're actually moving in the direction of the numbering. We're actually moving in that direction. Therefore, between 2 and 3, 2 should be the one chosen. And then on position 1, we have the alcohol. So first we're going to name up the substituent, which is the methyl group. And that is typically on position 3, as you can see. We need to start the name with a capital M. So that will be 3-methyl. That is basically it, isn't it? So we need to name this. This is actually going to be a pentanol. Pent, because we got 5 carbon atoms in the longest chain. So this is going to be 3-methyl pent 2-ene 1-ol. Now, you can see my use of the hyphens in it. If you want to separate between the numbers and the letters, you need to use a hyphen. And that is actually compulsory because you want to write the position of the functional group or the substituent. And so you must always separate the number from the letter with a hyphen. And so that is basically why you see all these. We cannot write pent 2 without this. Between letters and numbers, there must be that separation. So basically this is it. 3-methyl pent 2-ene 1-ol. Let's try it another way. So let's say that we got, and there is an NO2 here. Let us see, we got, so let's say there is another one here. Okay. So if you got this, what will be the name of the compound? As usual, feel free to pause the video and try working it out yourself. So as you can see, the functional group active here is fortunately just one. That is the alkene. So we're basically gonna start from this direction. So this is gonna be 1, this will be 2, this is gonna be the third, this is a fourth, this is a fifth, this is the sixth, and this is gonna be the seventh. Now, as a matter of fact, this place is gonna be a methyl group. So between M and N, which one is more alphabetical? That is the M, that is methyl. You got M, N before an O. So this is M and then N. Okay? So that is just what we got to do. Now the name of this will be, so I'm going to start with the methyl group. That is a 6-methyl. This is 6-methyl. And then 4 natural. Well, so I need to use a lowercase n. So this is a 4 natural. And then we're going to have the positions of the double bonds. Between 1 and 2, we got 1. That is because we're moving in this direction. So that is correct. That will be 1. And between 4 and 5, that is going to be 4. So we got 1 for diene. This is 7. So if we got 7 as the parent name, that should correspond to heptane in it. So that will be heptadiene. So this is 4 natural. Hepta 1 4 diene. That is going to be the name of the compound. Now try this one. What if you got this? If you got this compound and you were required to find out what will be the name of it, how are you going to do it? What is going to be the name for this compound? So the first thing we need to do, we need to find out the positions of each of the carbon atoms. If you see this functional group, you just got to know that this is a carboxylic acid. I've already shown this functional group in the previous video. Hopefully you have actually gone through that. If you have not, you really just know what to do in it. So I'm going to start my carbon atom in numbering from this position. This will be the first. So this is 1, this is the second, this is going to be the third, this is the fourth, this is the fifth. Now you see that there is actually something here. This triple bonds, they're actually situated in the middle. And that is not at the extreme end. So there must be a carbon atom at this position as well as here. And so this is going to be 6, this will be 7, and this is going to be 8. So we got 8 carbon atoms present within this compound. Now you could actually change it to its condensed form if you so wish. Let's try to change it. So first we got this. Yep. So if you see this stuff, this is the same thing as HOOC. If you don't want to write it that way, you could also write it this way, like so. Okay, so I need to rewrite that. Yep. And here we're gonna have a, so I think I'll need to, so this will be CH with a drop down BR. I'm just gonna write the BR here. There is 2 and 3 CH2s. So I might just well write it this way. 3 CH2s, and then this is 1, 2, 3. Now we got CC, okay, with a CH3, which there is actually no space to write the third, but I think this is actually pretty much it. So you could actually be given this, or you could actually have it in this way. HOOC. There is going to be CHBr. Then yeah, I'm going to have a CH2, 3. Well, so I'm having some problems. So this will be CCCH3. Yeah. So if you got this and you needed to write out the name of it, so we need to find out the presence of substituents, which happens to be just one of it. That is the bromo group on position 2 in it. Now we got the alkyne group on position 6 and 7 because as you can see, we're actually moving in this position, well, in this direction rather. So that will be between 6 and 7. So we're going to choose 6. So the name of this will be 2-bromo. So that is 2-bromo. And this is actually an octanoic acid, but there is an I. So I'm going to take this. So oct 6 inoic acid. Well, I'm just going to write it that way. 2-bromo oct 6 inoic acid. So that will be the name. Now let's take one final example. We might really use about 3 or 4 videos to understand how to name these compounds. So one video will actually not be enough. Now try this one. Well, okay, so what is going to be the name for this compound? Now, as you can see, there is a new functional group in town. This is the amido functional group. So we're really still going to begin from the side. So this is 1. This will be the 2nd. This is the 3rd. This is the 4th. This is the 5th. So should we go this way, 6 and 7, or should we go this way? So we're just going to move in this direction. So we are basically running in this direction. Now in condensed form, this will be, I think I'm going to write it like this. They could also write it this way actually. So you got CO. And here you're going to have a CH. We know this has got to be a CH group. And this is attached to a CH3. So this should be a CH3. Well, I think I'm going to reduce this. So this is a CH3. And here we got a CH2. And here we got a CH with a Cl. On this side there is also a CH. But we got something here. This is an isopropyl group. That stuff that looks like a Y. I'd already shown you this from the previous video. Check that out. So this is going to be CH, and then there is going to be a CH3. So I think I'm going to rewrite this. So this is CH. And then there's going to be a CH3 with 2 there. Then there is a CH again with the CH2. So this is typically, this is the condensed form of this line structure. So how are you going to name it? Which structure is actually more appealing to your eyes? Obviously, this is going to be the best one. So we know that there is actually 3 substituents in its place. First, we got the chlorine. There is a methyl. There is an isopropyl. Now the question is, should we use the methyl before the isopropyl, or should we go isopropyl first? Now you might actually say that iso goes before this one, but you need to understand that it is not actually the prefix for the substituents that we need to use. We need to take cognizance with its to its original name, which is actually the propyl, and that is a P. P comes after M. So we're not really dealing with the I, okay? So that doesn't work. So methyl will come before isopropyl. So we got chloro. That will be 4-chloro. So this is 4-chloro. Then we got 2-methyl. So this is 2-methyl. And then we got 5-isopropyl. Isopropyl. Then we got this stuff. So instead of doing that, I'm just gonna start with, because this actually is 7, which should be a heptane. But because we have this, that should be a heptamide or heptanamide. Now, because we got an alkene here, that would be a heptinamide, isn't it? So that is gonna be hep6 in amide, okay? So that is the name. 4-chloro, 2-methyl, 5-isopropyl, hep6 enamide. This is going to be the name for the compound. So that will be it for this video. Stay tuned for the next one. In the next video, we're going to learn how to name more complex structures than this, and also understand how to work reactions using this, as well as some various calculations on it.